Probably more important than introducing Charlie and myself, I need to introduce my wife. Diana, would you wave back there? And Charlie, I'll give you the chance as well.
And my very patient wife, Gail.
Let me tell you something. Probably as important as what we're doing is the support we get for what we're doing. And it starts at home. It starts with my wife, and I know Charlie would say the same thing with Gail. It's so important. There, as was said, where'd Tom go anyway? Over here. But anyway, there are many challenges in starting a company and seeing a great idea, a technology come to fruition. And when you know you've got the support of family and friends, the people around you that care about the outcome, that's critical. Because there's a lot of times we come home, Charlie and I have had a hard day, and you need that support. Of course, sometimes we make a presentation and we've had a great day, and Diana will say, "Well, that's great, honey. I'm glad you met the governor today. Would you take out the garbage?" So, I know you've never had that happen. We are doing something, I think, fairly extraordinary for an industry where the average four-seat piston engine airplane is 38 years old. An industry that in many ways for many of us is a passion, a love. It's an adventure. It's a part of our life. It may be our career, whether we're maybe a military, like both Charlie and I have military backgrounds originally. Some of you may as well. Maybe military and then civil. Some are more than half today of our pilots, of course, have gone through the civil system. And their first experience with a training aircraft is in an airplane with round analog dials and an engine that may be 4 decades old, 5 decades old, and of course burning leaded gas. And those are of course concerning items, but I think perhaps more importantly, it's a great part of our economy. It's a part of our national transportation infrastructure. There's national security issues, there's resource issues, so many things involved in this industry that we all feel very strongly about. And so a number of years ago, some 3 years or so ago, we began to look at the technologies that were emerging in ground transportation and trying to analyze them for the opportunity in aviation. You may think, well, a Toyota Prius on an airplane, that's relatively simple, right? And for those of us here in the audience that are engineers or any kind of technical background, I think you'll very quickly realize that it's not a simple translation from ground transportation to airplanes. Airplanes are extremely weight sensitive. Batteries, by their nature, as we know, are not light. And just recent advances in batteries make perhaps the application to aviation possible. I think we all know electric motors, and we see them successfully applied in all kinds of industries. Been around for decades, if not a century or more. Highly reliable, robust, but again, traditionally with very heavy casing, typically applied with torque in mind rather than horsepower in mind. And if you're a ground vehicle, of course, the initial torque to overcome the inertia, the weight of the vehicle, a locomotive for trains, an automobile or a truck, what a perfect application of an electric motor. But an airplane doesn't need torque. All we have to turn is a propeller. We're interested in horsepower, not in torque. And so the casing, the nature of the very beast, if you will, that is so exciting perhaps in the ground transportation sector, really begins to take on a different flavor, and it doesn't take a very deep look, and you begin to say, you know what? There are more challenges here than one might imagine. Taking a first quick look at the great emergence of alternative energy and applying it not just to ground transportation, but taking a look at what it might be to put it in an airplane. So in the last couple of years, we've taken a very diligent look. We've examined the concept and the background, the science, if you will. Charlie and I worked together with a great team of engineers, and through the last 2 to 3 years, we began to put together a business plan for what is now what we call the Green Flight Project. The Green Flight Project was launched in February. Tonight we're going to tell you a little bit about it. Traditionally, we don't like to do too much of a presentation per se. We like to be interactive. You'll see Charlie and I go back and forth. I talk about business, he talks about operations, and you know, you see something that's kind of interest to you. Typically, you kind of wait and hold Q&A to the end. We would invite you to be interactive with us. So some of you are friendly faces. Some of you are scientists, maybe, and engineers. Let's have a discussion about what we're doing and some of the challenges and what we think, of course, are some of the opportunities, in our view, of a vital part of the transportation sector, general aviation. Charlie is incredibly humble, an aviator for his entire life, an extraordinary aviator. He's got more hours than I can count in the airplane. Started in the Air Force as an Air Force fighter pilot, went on to Learjet, flew in the private sector for a while with some notable personalities, we'll say that. And then his career at Cessna, of course, over spanning decades, and ultimately, of course, leading the largest general aviation company in the world. And in my view, not necessarily reflecting on today, but certainly I think the extraordinary legacy that Cessna has is in large part because of Charlie's imprint there, the leadership, the vision that he had. And I have to tell you, I am extraordinarily honored to have a man of the stature of Charlie Johnson as our COO. Now, we have some additional leadership at the company, and we're going to see here in a minute. One of our business strategies has been to incorporate leadership throughout the general aviation industry, and so we're privileged to have other leadership here, and we'll show you here in a minute in terms of a business strategy, our approach. Briefly, I'm an Air Force guy, military background as well. Spent about 13 years in the military, then went into industry. Some of you may know from the Denver metro area here that we had the Aviation Technology Group, and we designed and developed the Javelin. We did that for about 10 years until the economy halted our Wall Street effort, which was necessary to take us into production. But that old entrepreneurial tenacity and passion, of course, Charlie and I met together with some leadership in aerospace and said, you know what, we're not going to quit. There are some vital things to do. And so, of course, that led to what we're doing here tonight. Charlie?
I'll just give you a little introduction to our airplane. We have gone through some iterations, and one of the things that we decided to do, and you'll see the word safety, and that's what we'll talk about all night, but we picked the safest airplane that has ever been built. Over 43,000 Cessna 172s have been built. We wanted to use a simple airframe. At one time we were starting with a new airframe, but what we're doing with this one is taking a proven airframe. We're not changing the flight control systems, any of the instrumentation in the airplane. All we're doing is taking a 160 horsepower engine out and putting a 160 horsepower motor in, and then we're replacing fuel with batteries, weight with weight. The electric motor safety has one moving part in an electric motor, as you all know. There are 900 plus moving parts in a piston-driven engine, and they're constantly fighting each other, multiple explosions. So just the tameness of the engine, the smoothness of the engine is going to add a lot to safety. A piston engine will generally go from 1,500 to 3,000 hours between overhaul periods. An electric motor ultimately can go between 20 and 30,000 hours of reliability. So the safety piece is something we feel very strongly in. Another part of the safety in the environment, we're taking out very volatile fuels, replacing them with batteries. The lower operating costs is substantially reduced. The maintenance is much lower, obviously, on an electric motor. The inspection cycles are much lower on the electric motor. The maintenance of the airplane will stay the same. Those inspections will be there. The operating cost is significantly reduced. Depending on where you are in the country, you can see up to a 10-fold reduction in the amount of operating costs to operate an electric motor versus a piston-powered internal combustion engine. If you take the worst case California high electric costs and the best case Midwest low fossil fuel costs, you still pick up a 6 to 7-fold reduction, and that's not really an apples-to-apples comparison. So significant operating costs, improved performance, higher ceilings, higher true airspeed, and higher climb rate. As many of you may know, a piston-driven engine is rated, if it's 160 horsepower at sea level, by the time you're at 4,000 or 5,000 feet, it's back to 140 horsepower or less, and the higher you go, the lower the horsepower it gets. An electric motor is 160 horsepower at sea level. It's 160 horsepower as high as you want to take it. So it picks us up a lot of performance benefits. The MTBF, that's mean time between failures, improved. Obviously, electric motor simplicity, annual maintenance. TBO is time between overhaul. Again, as I mentioned, electric motor, you're going to overhaul, take more an inspection, and completely take apart an engine and replace bearings and pistons and rings. And the environmental benefits, which are really the fun piece of this, greatly reduced fuel use, combustion, as I mentioned earlier, the engine's not going crazy. Very silent taxi, low noise flying, reduced pilot fatigue, and a couple of things are interesting. I think you all are probably all being progressive, have driven a hybrid vehicle at one time. Can you imagine taxiing in an airplane with almost no noise, and every time you stop, the propeller stops? So we're going to have some interesting human factors to work with to assure the people. And the other thing, which has become one of George and my favorite stories, we were at Oshkosh, the Experimental Aircraft Association convention, about 2 weeks ago, and had occasion to interact with a lot of people. But one of the most fun things we did, we were at the meeting with Cicada, the principal who owns Cicada, and his chief operating officer, and they were sitting with their back to the show, and George and I were sitting with our face to the show. And George is putting on his good business pitch, and all of a sudden my mind started wandering, and I'm watching this airplane. A motor glider came out, was flying a complete aerobatic routine in all the vertical, making zero noise. It's the most impressive thing I've ever seen. So I start nudging George, and he's nudging me back, and finally we got the Frenchman to turn around and look at it, and it just inspired us more to get our airplane flying. I cannot tell you how exciting it is to see a completely quiet airplane. No, there wasn't even propeller noise out of the airplane, and that's what we're going to contribute here.
I have to tell you, I still have a bruise on my shoulder. He was, trying to do this. It's like it couldn't have been timed better. A wonderful business interaction, and of course Charlie's heard it a few times, so he's kind of looking around, and here's this electric airplane going down Show Center, and roughly, I don't know, have any folks here been to Oshkosh? Have you had a chance? You've seen it. There's 70, 80, 100,000 people there any given time, roughly 500,000 or 600,000 over the course of a week. Probably the largest general aviation event anyway, anywhere in the world. The busiest airport during that week, anywhere in the world. So here, the crowd has stopped. They're all focused on this. Typically, of course, there's P-51s going by, and there's B-17s and F-15s doing flybys, and then the crowd goes silent. And of course, I'm so caught up with my conversation. Charlie's doing this kind of thing, and I'm going, "What, Charlie? What? I'm finishing my point here," and turn around, and here's this guy going right down Show Center, whisper, quiet. You could have heard a pin drop. I mean, 100,000 people just frozen in their tracks while this aerobatic routine is going on. It was amazing. And I have to tell you, with the characteristics of electric flight that Charlie was just mentioning, I think we're looking at the future of aviation. We really are. Well, at Oshkosh, the other reason we were there, of course, was to announce collaboration and support with Cessna Aircraft Company. Quietly behind the scenes, we've been working with them for a number of months, and Jack Pelton joined Charlie and I in making the announcement that we were working together on this electric Cessna 172, and again, that wouldn't have happened without the leadership and support that Charlie Johnson brings to our organization. So it's a legacy that we'll all be proud of, but I think particularly Charlie Johnson, again, leading the industry. In addition to Charlie, we're very proud of our team. Some of the leadership there extends over to Europe. Many of you know that Europe is very advanced in their application of alternative energy to transportation, and they're very interested, of course, in the aviation sector as well. And Alexander Kovalair, up there on the slide, is joining us as General Director of Bioenergy Europe to help us with the leadership of our effort in Europe as well. Some of the folks on the right-hand side are industrial and technology companies providing some of the detailed technology that we're applying in the airplane. Our Strategic Advisory Council is kind of part of the business structure of what we're doing, a little bit different than a typical startup business. Generally, you'd have your entrepreneur, innovator, a couple of key funding partners maybe, and of course the idea guys, the engineers. We have that too, but we're a broader, a little bit larger C corporation with private stockholders, and to kind of develop the collaboration and infrastructure, the broader possible reach throughout the industry, we reached out to the leadership that we've come to know. Charlie, again, many of these are through Charlie, some of them are through myself and my years in aerospace, and literally have been very fortunate in literally the leadership of General Aviation joining us on our Strategic Advisory Council. That has given us reach that a little company would not otherwise have. Jack Pelton, the current CEO, President, and Chairman of Cessna, is on our Strategic Advisory Council. Mark Van Tine, Jeppesen, many of you know here, another significant aerospace leader. You can kind of see Ian Massey, the former Airbus CFO. Beyond the Edge, Richard Sadin, some of you may know, right here in Broomfield, an aviation attorney and Quiznos CEO, many years. We're fortunate to have military leadership up there, the former Atom Aircraft, et cetera, et cetera. So, should we point out? Yeah.
While George is looking, there's one humorous piece. The lower left-hand corner, Joe Walker was another Cessna alumni, and as I was talking to Joe about it, and George had invited him to join our advisory council, Joe told me that he was the flight test engineer. He's a sales guy primarily, but he was the flight test engineer on the Cessna 172N. And he was about 2 seconds behind us in everything we were talking about. And then Greg Williams was in the lower right-hand corner. I don't think we mentioned him. If y'all are familiar with Williams engines, they provide all the cruise missile engines, a lot of small jet engines right now. They did the James Bond flying man pack that they had on there. They did the Chrysler turbine car. So Greg is an extremely innovative individual himself with an extremely innovative company. We just wanted to show you, we're not, pardon me, we're not the first in the game. There are a lot of people out there right now. We are going to be the first with a practical application that flies, carries people, and does a mission. We're in phase one. I'll probably say this a couple of times tonight, but we're very anxious and very aggressive in getting our demonstrator flying right now, and that's only phase one. Phase two will be a practical application, engine conversions to existing 172s, and we're also dealing with a number of other companies in some much higher horsepower, much more advanced application. George and I were talking about one today that goes up to 1,000 horsepower. So today what we're talking about is our demonstration concept that we'll have flying by either late this year or early next year. and as we go into the time, you'll see a lot more being done. This is a little outline of our airplane, the Cessna 172. You can see the various and sundry things on the top, upper right-hand corner, thin film photovoltaic solar panels will be on the airplane, electric motor generator replacing the internal combustion engine, a low RPM propeller. The ESUs are our battery packs, and then the VERDs, as George always calls, it's kind of our secret sauce. As you all might well imagine, an electric airplane and electric storage system gives us the capability of recapturing some of the energy that's created by the aerodynamic characteristics of an airplane. It also will allow us to recapture some of the energy when you're sitting at the top of your cruise altitude and you start a descent. You can logically take your motor and turn it into a generator and replenish. So we'll be one of the few devices that flies that will have energy available, more energy available in some cases when you get closer to the ground than you did when you started your descent.
So from an aerodynamic perspective, one might say, George, look, Cessna 172 is not the cleanest airplane from an aerodynamic perspective. It's got lots of parasite drag. It doesn't have a glider wing. It doesn't have the minimum thrust required in terms of the capability of keeping the airplane flying. Why not use a motor glider? And of course, if you recall the previous slide there that Charlie was pointing out, most of the electric initiatives today are in fact on motor gliders. Touring motor gliders using a battery pack, an electric motor to self-launch, or to recover from a scenario maybe where they're not in the best position to land, they execute a go-around or something like that. A safety motor, if you will, self-launch and a safety motor. That's a fine perspective from an experimental or research initiative. But the very point, and you recall when I first began our talk tonight, the very point of our project is to move general aviation into the future. Not the peripheral, not the edge, not the experiment, not the research, but to move the core of general aviation into the future. And the number one plane, bar none, in general aviation history is the Cessna 172. The perfect balance of control authority, thrust and drag. The training plane, actually, another one of our little favorite stories is we have our conference table, and we had 7 or 8 of our research engineers, and we're all beginning to kind of put together the team and move from concept into, okay, this is, how are we really going to get this done? And they were kind of having that same kind of feedback. Well, why the Cessna 172? And we kind of ran around the table and said, well, how many of you are pilots? And without exception, every single one of them had at least some pilot time. I think they all pretty much had their license even. The next question was, well, what did you learn? What aircraft did you learn on? And you know what? Every single one of them learned to fly on the Cessna 172. If you want to change an industry, you start with the point of entry. Where does it all begin? It begins with the training aircraft, the Cessna 172. If we can successfully transition this aircraft to alternative energy, to the electric propulsion and the hybrid approach, then we can move an industry. And of course, that's what attracted Cessna. That's what's going to bring the rest of the industry along, Piper and Cirrus and so forth, as we go into the future. So with very deliberate forethought, the Cessna 172 was picked. Now, there's other characteristics of the Cessna 172 that are also attractive. It's very robust. As Charlie points out, it's a sturdy, capable trainer plane. And of course, with its excess capability that allows us to carry more batteries and get the job, the first phase particularly, that we're working on now, accomplished in the very near term. Perhaps within the next 6 months or so. But Charlie will address that a little bit more later. Any particular questions here on this slide? This is kind of a fun one for those who are engineers or aero engineers. Yes, sir?
Range.
The question was, what about range? We speak a little bit more in terms of endurance, and we look at 2 hours, all electric, and an additional 2 hours with an auxiliary power unit in series, and I'll talk about that more in just a minute. But the idea is that we've set the table in terms of the layout of the system, where later, as battery technology continues to improve, the APU can be, in effect, unplugged and an additional battery unit plugged in. So we're kind of setting up a system, if you will, that today requires an APU, and tomorrow, we hope, relatively soon, next 3 to 5 years, we won't even need the APU. Okay.
This maybe will help a little in the explanation, the answer to that question. This is our weight chart right now, and I won't get into great detail on it. Very top line, we're taking out 400 pounds of engine, exhaust, fuel systems, and down at the second line of white, we're replacing that with a 48-pound engine. All in all, as we go down, the propeller, the cowl firewall, forward items, aircraft current battery, seats and upholstery, we are taking out 2 back seats. I would point that out here. And again, I will stress that this is our first proof of concept airplane, and this is the one that's going to fly. And then remove all the unnecessary avionics. We take out 1,386 pounds. When we replace the batteries, all of our control units, we replace 1,295 pounds. So we actually have a 91-pound reserve right now. And I heard a comment made earlier this evening about technology. One of the things that George just mentioned, we are banking on technology. We've already seen a 20% improvement in lithium-ion battery packages just since we started this. And when we get through with the project, we're going to have the endurance of the aircraft will be back up to 4 hours. We believe the battery technology is going to be such that we will be able to do it purely on batteries, but that's probably 3 to 4 years away right now. So in phases, we'll fly our first demonstrator airplane. The first time we fly, we'll only have 2 battery packs. It will be capable of staying up for 1 hour. The next flights will add 2 more battery packs in. It's going to get us up to 2 hours. And then as the technology evolves, we're looking at some small APUs to put back in, which will allow us to keep up to 4. But our goal is unequivocally to make this a total electric airplane. And to get that up to that time frame, we are banking on the future. And I know you all believe in the future, and you look at it, and we think it's very possible, and it's extremely exciting to watch the technology evolve right now. But again, we're taking out the 1,286 plus or minus and putting 1,300 and some odd pounds back in, and the airplane will be flyable exactly. We're not changing for the pilots and aerodynamicists in the group. We're not changing the center of gravity by 1/10 of an inch. We're reducing the empty weight of the airplane by about 90 pounds, and if anybody's been in airplane design, I'm confident that we'll blow that margin. That will probably be a little less than that 90 pounds by the time we get done. Again, proof of concept, we mentioned that earlier. We started the program, as George mentioned, on February the 18th of this year. Our rollout will be in the 4th quarter. The airplane is actually going through the paint cycle right now. We're doing some things with mock-ups and mock-ups of engines. We'll be starting to go back together in the 4th quarter. Our first taxi will also be in the 4th quarter with the airplane. And then either late in the 4th quarter of this year or early in the 1st quarter of next year, we'll be flying the aircraft. And it'll be flown out of the Centennial Airport in beautiful downtown Denver. George?
So this is a series hybrid. The APU is an auxiliary power unit. It's, in effect, converting liquid chemical energy into the electric energy so that, as Charlie points out, in the future, as the battery technology improves, the APU will be removed and an additional battery pack will be added. There is not a direct link between the APU and the propeller. The electric motor is providing the rotational energy for the thrust. Now, one of the things, it's kind of interesting, we're looking at slowing down the propeller rotational, the RPM of the propeller. Typically, we look at about Mach 0.8 for those propeller tips. Propellers themselves can get relatively noisy. So we're looking at this opportunity not just to reduce emissions from the burning of fossil fuel, but we're also looking at the opportunity to reduce the noise signature and create a little bit more community-friendly airplane. So it's not just the motor noise reduction, but also the propeller noise reduction. So we'll slow that propeller RPM down, go with the additional blades without the pulsing impact from the internal combustion engine. We're able to get a little bit lighter weight structure in the propeller blades. So they'll be a little bit thinner, composite, multi-blade, and rotate slower. So it'll be more of a fan type of a sound rather than the traditional propeller, two-blade Cessna 172 propeller.
Just one quick comment on there. As you can see in the upper right hand, the propeller notes, an engine right now turning 2,000 RPM, 6 cylinders, 12,000 times a minute, the propeller's getting hammered. An electric airplane, the propeller's just smoothly turning out there. It's not exposed to all those stresses, and that's one of the reasons we can make it lighter and use the different technology.
So we collect solar energy. We use that on the, unlike an automobile, we got lots of surface area. Now, it's not a profound difference, but it's significant in that it persists over some period of time. And if you're a Wyoming rancher, or you live in Canada and you're in a somewhat austere location, the solar energy will recharge your airplane in 2.5 days. You don't even need to be on the grid. If you're up here in Broomfield or Boulder and you're part of a smart grid community, you can plug in your airplane and that it's a solar collection. The batteries in your airplane can participate in the smart grid technology. So whether you're a Wyoming rancher or you're a resident of Boulder, in either case, the thin film photovoltaics are contributing effectively to the overall ownership experience of your airplane. We have some aerodynamic recovery, energy recovery, both from vortices on the wing tips, as well as Charlie mentioned through the propeller. Many of you may know that you use about fourfold the amount of energy to take off as you do to sustain flight. In other words, your initial thrust during takeoff, that 20 seconds of takeoff roll, 160 horsepower or so, is about 4 times the 40 horsepower you need to keep the Cessna 172 in the air. So there's a tremendous amount of energy exerted to accelerate the airplane initially and for that first few minutes of climb as compared to the amount of energy needed to sustain the airplane in flight or to cruise. All of that energy has been utilized and is available: kinetic energy, velocity, potential energy, altitude. And why not, just like a Toyota Prius, when you step on the brakes, recover some of that energy as you descend and decelerate. So the batteries then are more than just an initial energy storage unit, but rather they're a reservoir to give and receive energy as you conduct the flight. And of course, if you're doing lots of touch and goes, lots of training practice, how ideal to be able to recover some of that energy back. Of course, the computer system manages it for us. The batteries there on the left-hand side, again, the reservoir, and the display, of course, to the pilot up in the cockpit. And Charlie, I thought we had that slide, but maybe not. You want to talk about the display system?
Picture a display system. We are taking the RPM indicator that currently exists in the airplane off the internal combustion and we're replacing it with an electric RPM indicator. We're taking the fuel gauges, which show you how much fuel you have available, and basically replacing them with energy available that will be easily discernible by the pilot. And that's the only difference that the pilot's going to see in the cockpit. We're going to give a few more pieces of information to the individual battery packs, but the bottom line is if somebody's flying a Cessna 172 today, in our estimation, and we're working with the FAA and a lot of things, it will take zero special conditions to transition to the airplane. You're still going to push a throttle forward that's going to be in exactly the same location, exactly the same ergonomic shape. You're going to have a fuel selector down on the floor in exactly the same location. Instead of selecting fuel, you're going to be selecting a battery pack. But the airplane is going to be exactly what you're used to seeing right now. In our instrument panel, the only thing that we're modernizing, if you will, right now is the indication for the engines and the RPM indicator. Ultimately, as we progress a little farther, and we didn't want to put that complexity in now, we'll be going to full electronic flight instruments and crew alerting systems and everything else. But to keep the airplane simple right now, you'll just have that one simple gauge up in front of you that shows you the energy available. And one other point that I want to back up for 10 seconds. A lot of times we get asked, we're going to put about 750 pounds of batteries in here. We're replacing a 400-pound engine with a 50-pound engine, so that gives us about 350. We're taking out about 250 pounds of fuel, so that gives us up to 600. And then by taking the back seats out and locating the batteries in that location by not moving the CG, that's how we're coming up with the 750 pounds. And that's another reason we picked the 172. Yes, sir.
I'm just visualizing the steam gauges in a typical 172 or are you just getting rid of those, or are you going to keep the steam gauges?
Well, steam gauges are like in your car, you're used to seeing a round speedometer, and some of the new more modern cars have the electronic speedometers. We are leaving the analog or steam gauges in the airplane. Our first flight test and everything else will be done, and as George mentioned, a little bit of my background is test flying, and I like to take everything I can out of the test equation. All that we want in the test equation on this airplane is the engine being converted to a motor. So we'll be using the same pedostatic system, which is the reference system we get all of our information from, the same instrumentation in exactly the same locations. None of that's going to be changed at all. As you know, the newer Cessnas have the electronic flight instrument systems in them, but we didn't want to mess with all the interface on that. Ultimately, as I mentioned, we'll be working, and we already are working with avionics manufacturers, and we'll have an extremely modern panel. One of the things we're doing with Jepson is some flight computation predictives, and all that will be available to a pilot ultimately, but this first airplane is going to be round dials.
You go from a schematic with pictures to a schematic that engineers love. This is basically what you just saw in engineering speak, the architecture, if you will, of the electronics of the airplane. Motor, as Charlie just said, 400 pounds replaced with 50 pounds. 25% efficient with 95% efficiency. An absolute wonderful change. And of course, as we mentioned along the way, this is really good news for aviation because the characteristics of electric motors actually are much more conducive to the environment of the higher density altitude that we operate in with the airplane. Motors are controlled. Controllers provide, of course, the inputs between the throttle, the pilot inputs, condition the electricity and prepare it to move the motor at the RPM required to provide the thrust. Charlie was mentioning as we go into the future, we're going electronic, digital, providing again increased redundancy and safety and a much lighter weight than the analog system that we have in the system in the airplane today. Ascent Solar, located actually up north, not far from us here, providing the thin film photovoltaics between 1.2 and maybe as much as 2 kilowatts of energy. The thin film photovoltaics, literally thinner than a human hair. The entire coating on the surface of the wings measured in ounces, not pounds. A tremendous benefit, of course, ultimately, as I mentioned, to the ownership experience.
I have a question.
Yes, sir.
Replacing 300 pounds with 48, right?
Well, about 400 pounds. Yeah.
Yeah. Well, how much further forward does the electric motor have to be than the gas motor was to have the same moment arm?
Well, the moment arm and everything else we're doing, we're actually going to have batteries in the same compartment up forward. That's.
Okay, so part of the engine weight is...
Yeah, I should have made that clear earlier. The engine weight, the 400 that comes out, 400 will be going back in the nose. 50 of that's motors, 350 as ESUs. And then the rest of it will be placed on the same point that the current back seat and baggage compartment and fuel exists. And we've already worked those equations, so that's why there will be zero change in CG.
So you're not going to end up with that turbine converted beaver look where the...
No. As a matter of fact, George will show you in a minute, one of his happy slides is the redesign of the nose and the reduction of frontal drag with a very modern look.
The electric motor is 95% efficient. The other 5% inefficiency, if you will, is given up as heat. And so there is actually a fair amount of heat that is available, and of course it's just a pneumatic mixing then of cool outside air with the heat from the motor to provide cabin comfort. Now, in very cold environments, an Alaskan pilot may want to have a supplemental heater. In very hot environments, you may want to have a supplemental air conditioning unit, but pretty much for the majority of the utility, we do have the ability to mix the warmer air going across the surface of the motor with the cooler air from outside.
Because the entrepreneurial questions, one of the challenges we have with electric is to figure out what to do with the heat. So I mean, it's a very good question, but we will control the heat. And if we can take advantage of it, we'll use it. And as George indicated, as we go into further designs with the STC, we may have to take some of that power, or we may have to have a separate battery system to accomplish some of the heating and cooling and some of the very advanced avionics.
So you've actually eliminated the carbon dioxide indicator in that panel space too, right?
You know what? I love airplanes, and noise and fumes and things have been a part of the aviation experience. I mean, you hear the P-51s at Oshkosh, and Charlie's going to be flying some P-51s here in a few days, for about 3 days actually. It's...
My wife is looking when we go see Lee. It's kind of the cool part of the cool experience, I have to say. But this slide is a great example of the very thing that provides the energy, the chemical energy for the airplanes that we love is a volatile, explosive fuel. And when you take something moving very fast and you make it stop very quickly, that's dangerous. And we're very, we start the briefing. The number one thing we talk about safety. The very last thing we talk about in every meeting, every presentation is safety. And with great passion, we mean to make this a safer experience. And by removing aviation fuel or reducing the quantity significantly with an APU, we improve safety dramatically. So it's not just an environmental thing, as important as that is. We're also reducing the amount of fuel carried and the dangers associated, of course, with fuel. In terms of an industry, we're talking about the Cessna 172 as the point of entry for the aviation experience, learning to fly. When that expense exceeds $100 per flight hour, that gets pretty painful for those of us who look forward to perhaps learning to fly. It doesn't take too often, too many flights to go, you know what, this is really expensive. And so if you can reduce the cost of enjoying this flight experience, as Charlie said, by 5 to 10-fold, depending on the area of the country, the cost of electricity, of course, much different in the Northeast than it is here in the Mountain West. Still, that significant reduction in the cost of the flying experience, we think will be an invitation to enjoy flying and share in this experience that we all love. Designed for human factors in mind, battery units need to be serviced, technicians need to take care of them, so we very much have this in mind in the design now and for the future. Charlie mentioned the configuration in the cowl. The motor in front
immediately followed by battery units, again, keeping the weight and balance the same. You can see with some of these next pictures how it lays out. And as Charlie mentioned, I love the fact that we reduce drag on the airplane. And the lower profile of the electric motors allows us to do that. There's the motor layout. Oops, there we go. Motor and controller. Some more images of the lead candidate for the motors and controller. Again, a schematic of the two battery system that we're starting with that proof of concept airplane. The display unit that Charlie was talking about for the pilots. Of course, before you put things on airplanes, you want to test them on the ground. Before you fly, you want to do thorough tests on the ground. And even as you fly, you take very safe, progressive steps, adding complexity as you add time. We have about 1 kilowatt hour of energy used per minute of flight. First flight will be 10 or 15 minutes, and we'll progress, of course, in the amount of time we fly from there. Some further research that we're doing. The sponsors that we talked about initially, again, part of the business plan and in increasing the number of participants in the project. And then ultimately, we come back, of course, to what we began with, and that's safety. Charlie?
One quick input in case y'all caught it. Our proof of concept airplane is going to have two motor segments. The ultimate airplane will probably be one, but I just wanted to make, for those of you who caught that on the slide, the 48 pounds worth of motors are two motors coupled with a shaft. So I know there are a lot of engineers and very sharp minds here, and I didn't want that to escape. And again, as George said, that we're right back where we started. Safety, lower operating costs, lower maintenance costs, significant environmental benefits, and we really are looking forward to getting the airplane flying and showing it to people. Yes, ma'am.
I know we're running out of time, but could you elaborate a little bit on the reduced pilot fatigue?
Reduced pilot fatigue is much lower noise levels, and again, as I keep mentioning, that you don't have the engine hammering away at you. That all those vibrations go away, so the noise and the vibrations go away. Much quieter, much smoother environment. Yes, sir.
Yeah, can you touch on your relationship with the FAA and the certification?
I love that question. We have been keeping the FAA, with the Aircraft Certification Office, very up to speed. We're going through certification issues. We actually met some potential partners up at Oshkosh. We are totally open with the FAA, all the way from Denver, all the way through the most senior levels, and we have some friends back in Washington that are helping us. In my personal experience, I spent about 35 years in the certification world, is if you're open and you understand that the FAA, they're not bad people. They have requirements, and it's incumbent on us to either meet the requirements or help through mutual education to come up with requirements that are reasonable. We're working very cooperative with them, and I think it would be an understatement to say they're very enthusiastic about what we're doing for the future.